I am here to discuss about logarithms. In this class, you will get a clear idea about logarithms, its properties, and how to solve the problems by making use of logarithms. Logarithm is a rule to simplify some mathematical calculation. And we know that logarithm is defined only for positive real numbers. Suppose n is a positive real number, then it can be expressed in two ways, either in exponential representation or in logarithmic representation. Okay, that means suppose we are considering a real number that is greater than 0, then only logarithm is defined. So it is a positive real number. Now, this n can be represented in two ways, either in exponential representation or in logarithmic representation. Okay, for example, let n is equal to 36, a positive real number. I can represent this 36 as 6 into 6, that is equal to 36, or 6 square is equal to 36. This is the exponential representation of the number 36. Here, this 6 is called base, and this 2 is called either power, degree, or exponent. That is, either power, degree, or exponent. And this 36 is our positive real number n. Okay. In logarithmic representation, we can represent the number 36 as log 36 to the base 6. This is the logarithmic representation, and this is read as log of 36 to the base 6, and this is read as anti-log of 2 with respect to the base 6. Here 6 is the base and 36 is our positive real number. The answer of log 36 to the base 6 is 2. Here also 2 is called power, degree, or exponent. This is either called as power, degree, or exponent. So in both these cases, base is 6, exponent is 2, and the number is n. So there is no change for base, number, or exponent. That remains the same. So this is a different representation of a positive real number. In general, the exponential representation is a raised to x is equal to n. This is our exponential representation. Okay, here a is the base, x is the exponent, and n is the positive real number. This a raised to x means a is multiplying x number of times. That means a into a into a into up to a x times. This is equal to n. Okay. In logarithmic representation, that is denoted by LR, we can represent as log of n to the base a is equal to x. Okay. This is also called anti-log of x to the base a, and this is called as log of n to the base a, that is equal to the exponent. Now, n is greater than 0. So for this, we are multiplying ax number of times, we will get n. Suppose base a is equal to 0. Then what happens? 0 raised to x. 0 raised to x is always 0. Right? 0 is multiplying x number of times. That is always results in 0. So base should not equal to 0. That is, base not equal to 0. Suppose a is equal to 1 or base is equal to 1. What does that indicate? That indicate 1 raised to x. That is equal to 1 into 1 into 1 x number of times. That is equal to 1. Always 1. 1 raised to any real number, that is always is equal to 1. So base should not be equal to 1. That implies base a should not equal to 1. So we can conclude logarithm of n to the base a is equal to x, where a is greater than 0, a not equal to 1, and n greater than 0. Now consider log n to the base n. What that indicates? That indicates n is multiplying how many times to get n. So this we can write as in exponential form, the base raised to x, that is equal to n. This is the exponential representation. Now how many times n is multiplied so as to get n? That you have to multiply only one time. So x is equal to 1. Right. Now consider this property. Logarithm of n to the base 1 by n. Right. So how many times 1 by n is multiplying so as to get n? So we can represent this in exponential form as 1 by n raised to x, that is equal to n, or n raised to minus 1 whole raised to x is equal to n, or we can write this as n raised to minus x is equal to n raised to 1. Now comparing the powers in RHS and LHS, this implies s is equal to minus 1. So these are our properties, three very important properties. That is, logarithm of any number to the base a is x, provided base is not equal to 1 or base not equal to 0, and logarithm of any number to the base of the same number. If the number and base is same, then answer is 1. And similarly, log n to the base is the reciprocal of that number, then that will result in minus 1. I think it is clear, right?